Hi everyone and welcome to Autodesk PowerMill, the complete course. So we have already started the module number 3, which is all about the 3D toolpaths and machining strategies. And what we have done, we have covered the model area clearance, model rest area clearance, model profile, model rest profile. So today we are going to start the slice area clearance and slice profile. So we discussed what is slice area clearance and slice profile. So let's get started. So we are using the Autodesk PowerMill Ultimate 2024 and we need to load a model into PowerMill. So just click on the models and right click, import the model. So we have a lot of examples present here. So I'm going to use an example as a cowling.dgk. It's a simple example. And generally we use all these type, or you can use any other type. Like we have die and cowling. So most probably using the cowling.dgk file. Click open. And here you see the model is loaded. So it's a surface model. You see a surface. It's completely inside and it's outside. So it's a surface model and we have loaded it. So I'm not going to do any creating any work model or work planes or all this stuff. I'm just going and apply some certain default settings. So the first thing is that what is slice? As I give you a simple example, you did your breakfast every day and use a bread. And there is a bread, we have different slices. So each slice we take out from the bread is called the slice. So what we are going to do is we are going to create a boundary or create a pattern on this model and say that this is a slice, and you have the model toolpath strategy is going to be applied on that certain area of that certain pattern or boundary. So either we are going to apply the area clearance. As you see that we have to apply two things here, the area slice clearance. So the selected area, the machining toolpath will be created inside that area clearance. And the slice profile is literally equals to the 2D curve profile which we have done in the previous module. So let me show you how we can apply the model's slice 3D area clearance. So go to block and apply some stock material. Click calculate, accept. And you see that my work plane is placed over here. Okay, so I'm not going to change my work plane. I'm just set as default. And what I'm going to do is I'm going to create a pattern. Or we have two options here. You can either create your pattern to define the slice, or you can easily create a boundary to create a slice. So it depends upon you. What I'm going to do, I'm going to select a pattern. So right click on the pattern, select the curve editor, and here you see the curve editor is open. There are certain tools like create curves, lines, circles. So what I'm going to do is I'm going to select the composite curve. It automatically traces over the existing curve or surface edges. So just click on the composite curve, click here and follow the curves. So you can either use this forward and backward to select your curve. So I'm going to forward this, and this. So the curve is defined successfully. Just click and on the save composite curve and click OK. So you see that this is my composite curve which we have created, and this is a 3D composite curve. Now I'm going to right click on the pattern and named it as a, where is name? Here is the rename, and set as pattern 1. That's pattern 1. Now select the tool path and go to 3D area clearance as we are performing the 3D area and 3D machining, and you see that slice area clearance. So in the slice area clearance, we have selected this slice, and on this slice the cutting tool will perform on this section. Okay, and you see over here that we have selected the composite curve over here, and it just projected on the top of the side and create slice of that area. On that area, and within that area, the cutting tool will perform its operations. Okay, so just click on OK, and you have to define this slice area clearance by name. So I'm going to write that this is a slice area clearance operation. And we have defined the block. We need to define the tool. So I'm going to select a tool which is flat ended mill tool, which is 5 mm, 5 mm flat, F for flat, E for end, and M for mill. Next thing is you have to define the diameter. As I have written the name 5 mm, so just select 5 mm length. Should be this to 5 mm. The next thing, you have to define the number of fluids. Yes, 4 number of fluids, and the tool number is 1. And just go to slice area clearance, and here you see that all the cutting operations and cutting parameters are being defined on this side. So the first thing is that slice area clearance, we have this tile. So you have to select this tile and the slices. So we have created a pattern, so I'm going to select the pattern. If you have selected or create a boundary, you have to select the boundary. Right now I'm going to select the pattern because I have a pattern here. Click on the pattern and go to offset all. So we have to define this tile. Either it should be the raster, offset model, offset all, or in a vertex style. So in raster, you know that the cutting tool and the tool path is created at an angle. So it should be a 0 degree angle, 90 degree, 45 degree, or any angle which you are going to define. In offset model, it just should follow the model appearance. In the offset all, should span around all the things. And the vertex should be irregularly create patterns and cut that within that the selected pattern. Okay, so for that simple I'm going to select the offset model, and the cut direction is climb and the radius climb. Set the tolerance or to top of the accuracy 0.01 millimeters, and the thickness. If you want to retain some material on the bottom side or on the wall side, or we can say that on the wall and on the floor. So you have to define the thickness of the material which you don't want to remove. So I just said that I don't want any thickness on the wall and on the floor, so just set it 0.0. And the step over should be 2.5 because I'm going to set my tool 5 millimeters, and 2.5 means it's going to be used to 50% of cutting area of that tool. So offset settings is okay, step cutting is okay, work finishing, all these things are okay. Just go to rapid positions, rapid move clearance, and go to rapid moves. Just click on calculate, go to lengths, and go to this part and set as straight, and that should be the same. Go to feed and speeds and set the spindle RPM to 5000 RPM, and cutting feed is 1500, and plunge feed is 150, and all these things. If you want to set the coolant, just select the flood coolant for this. Just click on the calculate and the cutting tool will be selected. So it shows a warning that the cutting tool is plunged into the stroke. So if you want to continue, just click on OK, or you can set as lead in and lead out for the cutting tools. Okay. So what you see over here is that we have created a pattern on this side, and on this side the pattern is being projected on this surface, on a certain surface, and it just creates around the clearance area on that selected pattern. So this is what we call the slice area. So this projected pattern on this side is create a slice on that area and cut down the material. So it mostly defines on and work on the flat surfaces, not on the curved type surfaces. So just want to show you how it works. Okay, just go to simulation and click on the toolpaths and control fade, and this is how it works. So we have set it that the cutting tool is going to be work in a offset model. So it's just creating the tool path in a type of offset model. It's creating a step over of 2.5 millimeters. So this is how the slice area clearance works. Hopefully you enjoy it, and hopefully you understand how to create a slice area clearance. So that's it for today, and thank you very much.